Change of variables in double integrals. Change of variables in double integral. Some double integrals may be easier to evaluate if they are expressed in terms of new coordinates u, v. The simplification is twofold: simplifying the shape of integration region and calculating the iterated integral. Theorem 24. Suppose a transformation x is x uv, y is y uv, has continuous first order partial derivatives. Suppose that this transformation is one-to-one and has a non-vanishing Jacobian. Then double integral on d f xy dA is equal to double integral on d new d area f x function uv and y is function uv and absolute of Jacobian and the new dA, new transformation area. Definition of Jacobian. Definition of Jacobian. The Jacobian of transformation T defined by x uv and y is y uv Jacobian is partial derivative symbol xy, partial derivative symbol uv. This is symbol of Jacobian is equal to determinant of x y u v x is independent variables and u and v new variables. So x u y v minus y u x v. This is calculation of Jacobian. So now double integrals in polar coordinates. The transformation of a double integral to polar coordinates is just a special case of a general change of variables formula. So this is Cartesian coordinates x, y, and polar coordinate is rho and v. This is rho and v. This is x and y. And so x is equal to rho cos phi and y is rho sin phi. Jacobian is xy rho phi. So firstly x rho x phi y rho y phi and cos phi minus rho sin phi sin phi rho cos phi. Jacobian is rho cos square phi plus rho sin square phi is equal to rho cos square phi plus sin square phi is 1 and Jacobian is equal to rho for polar coordinates. And this is we are now ready to write down a formula for the double integral in terms of polar coordinates. Double integral on d f x y d a. And now if we try to x y and this we think this area. This angle alpha, this angle is beta, and this border phi is beta, this border phi is alpha, and this border rho is A, this border rho is B. And in polar coordinates, D goes to new D, and F rho cos phi instead of X, rho sin phi instead of Y, and you remember jacobian absolute of this is rho for polar coordinates and d rho d phi. We calculate double integral this formula for polar coordinates. Now, example. Evaluate double integral on the x minus y divided x plus y dA, where d is xy, so x is bigger equal 0 and y is bigger than bigger than is 0 and x plus y is equal smaller than 1. Note that evaluating this double integral without using substitutions is probably impossible, at least in a closed form. By looking at the numerator and denominator of the exponent of a, we will try the substitution. U is x minus y and v is x plus y. The given region D is shown. We draw x, y. So x plus y equal to 1. So 1, 1. This is x plus y is 1. The area is x bigger than 0. X bigger than 0. And y is bigger than 0 and x plus y smaller than 1. This area. This area is D. To find the region nu D in the UV plane, observe that the size of D lie on the lines y is equal to 0, x is equal to y is equal to, this line is y is equal to 0. This line is x is equal to 0, and x plus y is equal to 1. And u is x minus y, v is x plus y. So x is equal to 1 divided to u plus v, y is 1 divided to v minus u. Using the transformation equations, we said that the size of nu D corresponding to this size of D are bonds in the xy plane, bonds in the UV plane. X is equal to 0. X is equal to 0. So 0. So v is minus u. Y is equal to 0. V is u. And x plus y is equal to 1. So x plus y is equal to 1. V is 1. We draw the new area. This is u and this is v, and v is equal to minus u, this line, and v is u, this line. V is equal to 1, this line. This area, this is v is equal to minus u, this is v is equal to u, this is x plus, sorry, v is equal to 1, minus 1 plus 1, this is 1, and new area is now. Transformation of Jacobian. Now Jacobian is x y del uv. This is x y u v, and this is transformation and calculate easily xu 1 divided 2 xv 1 divided 2 minus 1 divided 2 1 divided 2. So 1 divided 4 plus 1 divided 4 is equal to 1 divided 2. So by theorem 24 we obtain dx x minus y x plus y dA is equal to nu d and exponential u divided v jacobian nu dA. Regarding nu d as a u simple region, please. This is u simple region. We write the iterated integral. This is u simple region goes to 0 to 1. Lower boundary this line, upper boundary this line, and we write easily nu d 1 divided 2 exponential u divided v nu dA is equal to from 0 to 1. From u is minus v, u is plus v. 1 divided 2 x u divided v du dv. We calculate and from 0 to 1 divided 2 v x uv u is minus v, u is plus v dv. We write minus v and plus v on the u instead of u. This is constant, goes heat from 0 to 1 v x minus 1 dv, and one divided 2 x minus e integration of v 1 divided 2 v square, and we write 1 divided 2 is equal to 1 divided 4 x minus 1 divided x is equal to e square minus 1 for e. This is solution. Transformation is very important. If you don't use the transformation, you cannot calculate this integration. Another example. Evaluate double integral on d dA over the plane region bounded by the four parabolas. The four parabolas. Y is x square, y is 2x square, x is y square, and x is 3y square. Now, letting u is x square divided y and v is y square divided x. You can determine the bounds for region nu d in the uv plane to be, we calculate now. 1 minute. First we draw this the region. This is region. This is x, y. Now this is y is x square and this is y is 2x square and this is x is y square and this is x is 3y square. Araya this araya d. And now if you say y is x square, so if you say u is x square divided by u is 1 and if you say y is 2x square, y is 2x square, u is 1 divided 2. And if you say x is y square is v is 1 and x is 3 y square is v is 1 divided 3. So transformation new variables u and v, new boundaries 1 divided 2, 1 divided 3, 1. New d array transformation. And now Jacobian is determination of x, y and del u v. If you don't if you don't want to calculate inverse transformation, you can use these specifications. This Jacobian is equal to 1 divided this Jacobian, inverse Jacobian. So we calculate easily this Jacobian because we know this. So del u, del v, del x, del y is determinant of ux, uy, vx, vy. So determinant 2x divided y minus 2x square y square minus y square divided x square 2y x determinant. And then firstly, and then 4 minus 1 is equal to 3. Jacobian is del xy del uv is equal to 1 divided 3. So double integral on d dA is equal to new area is this area and Jacobian 1 divided 3 and dA, and new area is this area, so simple area, and u from 1 divided 2 to 1, and lower boundary is 1 divided 3, upper boundary is 1. So 1 divided 2 to 1, 1 divided 3 to 1, 1 divided 3 dv du, and then is equal to 1 divided 2 1, 1 divided 3 v, 1 divided 3 1 du, and then 1 divided 2, 1 divided 3, 1 minus 1 divided 3, this is 2 divided 3 and du, and 1 divided 2 1, this is 2 divided 9 du, and then 2 divided 9 and is equal to 1 divided 9. This is solution.